Hello everyone. I'm very happy to be here today to talk about automated game testing. This is a presentation I've done a few weeks ago for the Automation Star conference in Vienna. The presentation has been written for people with test automation knowledge, especially in web or mobile apps. And the idea was to make people with test automation knowledge to get curious about automated game testing and provide these people with pointers so they could get started faster than it took for me. I know that a lot of people here are not necessarily the initial target audience, but if you work in video games, and especially in QA, I think it can be interesting to learn from what I have to say today. If you have any question, please post a comment on LinkedIn, and we will go through them after the presentation. We have roughly 15 minutes dedicated to that. So post your comment and I will read them at the end of the presentation. So let's get started, and let me tell you first how I became a QA automation engineer in the game industry. A long time ago, I used to work for Mozilla, the company behind Firefox. I've been working as a web developer, both on front ends and back ends. And if yourself you have been working on web apps, you know that test automation in this area is not something new. Then I worked for Sauce Labs. And if you don't know them, they provide cloud-based solution for web and mobile testing. You write the testing code and they manage the browser version and the physical and virtual mobile devices for you. It's nice because you can focus on your tests instead of maintaining your device file. And at this time in my career, I was working on my spare time on small games. But something I was used to when developing web apps was missing for video games. And this thing was automated testing. How the hell do you write test automation for video game? There was no framework, no tutorial, no resources to do that at the time. So I got an idea. If I can figure out how to build a test automation solution for game engine, then I can provide a cloud solution like Sauce Lab does, but for video games. That's when I launched a cloud platform named Game Connector to do exactly that. Unfortunately, it was not successful. And the reason is most game studios don't have the skills in-house to write automated tests. So they don't have the need for my platform. Instead, what they do is they rely heavily on manual testing. So I decided to join a game studio to build that test automation infrastructure for them. Wuga is one of the biggest mobile game developers in Berlin, where I live, and it has seen a huge success with June's Journey, their top mobile game in the hidden object category. Everything I'm telling you today has been learned from the past decade, first as a web developer and then as a QA automation engineer. Let's start with one question. Why are video games so unique to test? A simple answer is games are interactive experiences. There are a few words here, but the last two are very important. Games are interactive, much more than any traditional app, in fact. While a website has some interactivity, it's usually very succinct, and its purpose is to help the user achieve their goal as fast as possible. Games are also experiences. They are created to keep you engaged. This means, contrary to a traditional app, a game will employ counterintuitive design principles. For example, tension might be manufactured. Think swarm of enemies, suspenseful stories, action-driven gameplay. Obstacles are put in place to prevent the character and the player from achieving their goal right away. In a lot of games, failure is a big part of it. It's not a big deal in the game to fail. But failing to achieve what you want to do in an app is considered a huge problem. So with this in mind, we can't approach game testing the same way we do web or mobile app testing. One immediate consequence of that is the essence of the game might not be tested automatically. A game must be fun and engaging. You won't be able to test that automatically. Me telling you that might sound paradoxical because I'm here to talk about test automation after all, but that's very important because you need to decide what should be automated or not. Making such decision is part of QA automation engineering, even more so in video games. To continue on things unique to games, let's roughly map some of the important traits they share. A game often has goals. A large portion of games drive tensions through conflict in their stories or in their gameplays. Think of competitive multiplayer games, for example. An important part of being good at a video game is to know and understand its rules. Rules that can determine win or lose conditions. So if we were to summarize all of that, we could phrase it as follows. Games provide friction to the user. This is very different from traditional apps, where friction is not considered a good thing. But what does that mean in the context of testing? It means that if games manufacture friction, it has its own agenda. The game doesn't necessarily go at the pace of the user. Instead, it imposes its own pace, its own rhythm. When interacting with a web app, it's very rare that you are time constrained. Usually this is done for security reasons, like when there is a timeout, for an session to expire, for example. But in video games, timers, countdown, cooldowns are everywhere. For example, here is a hidden object level from June's Journey. The bonus is some kind of timer telling you how much time you have to find the next clue before losing the bonus. The light bulb in the corner gives you clues, but if you activate it, it has a cooldown, and you won't be able to use it again before the cooldown is off. Another example from Clash of Clans is shields. Shield protects you from enemies for a period of time. It has a cooldown spanning days. This is interesting because in video games, you have game time and real time. If a timer is in game time, you can split the game clock and the timer will go faster. But in real time, the game going faster doesn't change the timer, which is problematic when trying to test for it. Another example of that are live events, where special elements of the games might be accessible only during this range of time. Again, not easy to test, because it requires cooperation from the backend outside of the game client, since this data is really inside the game itself. So when writing an automated test for it, you have to keep that in mind at all times. Getting your test to deal with the game's agenda is a big part of designing the automation. Moving on, another thing that makes games different is the way they are built. In web development, this is usually a good idea to separate parts of the system from one another. The goal is usually to be able to introduce changes without affecting the system as a whole. This is easy when designing web applications because what you do with web apps is usually an aggregation of small disjointed actions. Searching doesn't have to be exactly consistent with how you view an item. Modifying an item is often an entirely different interface than viewing inside item. But in games, this is very common to do all of this in a very consistent way. For example, your inventory might be diegetic. Diegetic means the inventory you see exists within the world of the game. It's not just a menu. Here you can see an example with the forest, where your inventory is literally your backpack spread on the grass. If you need to collect something, location and physicality matter. You cannot just add something to your inventory. You need to go where the item is first. And you need to go where it is in the world that is presented to you. Modifying and customizing an item might also require a specific location. Here we can see an example from The Last of Us, where you need a bench to upgrade your weapon. These benches are not available all the time. You need to find them in the store. All of this requires, to some degree, systems that interact with each other. As a consequence of that, this makes them likely to be coupled. What this means for testing is that the classic testing pyramid might be questioned. If the system you're building is more coupled, unit tests will be less useful than integration tests or end-to-end tests. Most of your bugs will be found in the interaction between the different systems of your games. In other words, The lesson here is testing your game system together becomes more valuable than separately. Now, what do we see here? We see a collection of platforms, tools, and other elements commonly used to build video games. And maybe you might think, well, this is not very different from web development or even web test automation, where a new JavaScript library shows up every day of the week. And on the surface, you wouldn't be wrong. The web ecosystem is vibrant to the point it might be overwhelming. However, there is a strong distinction. All of the major game engines are strongly incompatible with each other. Learning how to do something in Unity won't be transferable in Unreal or Godot. The tech stack is different, the interface is different, and the capabilities are also different. And this is without accounting for the console platforms, where not only the hardware architecture is different but building software on them requires dev kits that are often the source of gatekeeping by the platforms themselves. On the web, on the contrary, the vast majority of things are built on top of web standards. This means a test running with Chrome is likely to run on Firefox or Safari. This leads us to my fourth point, explaining what makes games unique. The video game ecosystem is fragmented, and it severely lacks any standardization. What are the consequences for test automation? In my opinion, the consequences are pretty bad, because I suspect this is the number one reason why test automation tools are lagging behind in the game industry. Until recently, for game studios and individuals, it wasn't very interesting to invest into test automation. On one side, because game studios had a hard time finding individuals with the proper knowledge, and on the other side, because individuals couldn't apply what they learned from one company or any other game to another. After all, every game is different, so trying to apply lessons learned on one side can be complicated. Let's recap. What makes games unique for testers? You cannot reasonably test the essence of a game automatically. You need to keep in mind the game's clock. Integration tests are more valuable for your games, and you need to be aware of your technological choices because the game dev space is fragmented. So the choices you make today will be hard to revert in the future. Now that we've learned what makes games unique, is writing test automation for them alien territory? Or can we still learn from other industries? And of course the answer is yes. In this section we will see what can be transferred from web testing to video game testing. The very first thing I applied to automated game testing was to translate the concept of page objects to video games. For video games, this is only slightly different. Why? Because games do not have pages, but they have screens. That's why, when I'm referring to this pattern, I talk about screen objects instead of page objects. And the same way page objects are a good way to reuse code dealing with parts of the UI of a web page, screen objects do the same thing for specific parts of your game. It is very often UI-centric. For example, it is excellent for menus that comes again and again through the game. Here is in June's journey, if we come back to the example I shown before, you might have a single screen object for the main gameplay. With it, you might want to prop the state of the bonus, so you can know if the bonus is active or if there is a multiplier. You might want to be able to click on the pause button or trigger the light bulb to get a clue. What do we find in screen objects? We find locators used to interact with the UI elements, methods to probe information available in the game. Often it will be data displayed to the player, but it can be more discrete data. Data that is available in the game set but not necessarily known to the player. You will find abstracted interaction with the game. So for example, opening a menu, or going back to the previous screen, or buying an item. And you will also find synchronization methods. which is my next transferable knowledge on the list. So synchronization. This one is a bit different because it's not exactly something you deal with constantly in web testing, but it happens. And in test automation, you have this notion of implicit waits and explicit waits. Implicit waits are a built-in way to automatically wait for an element, while explicit waits are ways you write yourself, making them explicit instead of handled by your testing tool. Unfortunately, in video games, you can only use explicit waits at the moment. You have to write everything yourself. So for example, often you will have animations, and you will have to wait for them to be completed before triggering your next interaction. So this is a way of synchronization for your testing code with the game. Interactions. Simulating input is an important part of test automation. For the web, the interactions are standard and well-defined. You very rarely go off-road. Video games, however, often do their own things. Of course, game engines provide you with regular UI elements to build some UI, but even for 2D casual games like June's Journey, some of the gameplays will be built with custom systems of interactions. This means some of the interaction done in your tests will have to be written specifically for those cases. However, both in the case of the web and video games, building good automation requires you to go beyond standard interactions. And this can be summarized in one question. How do you know if your interaction had an effect? Humans know how to retry clicking on a button if it didn't work the first time. But with automation, this becomes a tricky problem. In video games, this might happen even more often than in other areas, because, as I said just now, previously, the interaction systems are regularly custom built. When it comes to automated testing, how do we tackle this problem? The way I address this is actually simple. I use a pattern I call guarded interactions. It's a class that wraps around an interaction and takes a pre-condition and a post-condition. This is something that has been inspired by Chris Lauder, a regular speaker at test automation conferences. The idea is actually quite simple. Before the interaction can be performed, a precondition needs to be fulfilled. And after the interaction has been successfully executed, a postcondition is also expected to be fulfilled. Let's give an example. Imagine you have a button opening a menu. What would be a good precondition before you can interact with this button? Maybe the button must be active. Maybe it needs to be rendered. Maybe the button must be inside the viewport for the player to have a chance to see it. When one or all of these conditions are fulfilled, we perform the interaction. That is, in this case, we click on the button. Now, what is a good condition expected to be fulfilled after the button is triggered? Well, this is a button to open a menu, so we could confirm the menu is active in any way possible. This covers a lot of edge cases, especially when interacting with the UI too soon or too late would be a problem. It's also a good pattern to introduce retries. One more lesson that can be transferred from web test automation is locator strategies. Again, on the web platform, things are pretty standard, so how do we do it in video games? Well, locator strategies, it's once more completely left up to you. Each game engine organized its game object differently and provides some programmatic way to retrieve objects, by name, by class, by tags. And when I mean classes, I mean type classes, not CSS classes. So for each game engine, the way you will retrieve these elements in your screen objects will be different. The same problem can be observed on the web, and in video games, however, you need to use specific attributes for your elements to guarantee some stability in your test. Your test should be resilient to some degree of UI shuffling. This reinforces the need for screen objects, because if one of your locators is broken, you should fix it in one place only. Let's recap once more what lessons from the web can be applied to automated game testing. Use screen objects, especially for your game UI. Write custom explicit weights whenever you can. Check the effects of your interaction with the guarded interaction pattern. And use precise locators and have them in one place for them to be fixed quickly if needed. So we've learned what makes games unique in terms of testing and what existing knowledge in the web and mobile field can be applied to automated testing for video games. So if we were to start writing tests for video games, where should we start? The first step is to choose a programming language. Maybe you're used to have your favorite language being supported by many of the test automation tools built for the web. But in video games, since the tools are quite new, you will have to make a choice. Python is a good choice if you want to stay agnostic. However, it is not native to any of the major game engines. Why does it matter? Because choosing Python will restrict you to use tools instrumenting the game from the network. It might not be a big deal, but it adds another layer of complexity. Remember, games have their own agenda, so adding network latency means it might result in some flaky test. It depends how you build it, of course. Unity's language of choice is C#. If you want to write test automation for Unity, this is quite good, because not only you will be able to write tests for it, but you will also be able to understand the internals of the game, which comes really handy when writing some advanced tests. Something that is not purely black box driven test, but something that uses the internals of the game, for example. C++ is the language used when programming with Unreal. So if you want to write tests for it, you will have to know C++. So as you see, depending on the game engine you're choosing, this might have an impact on your choice of tools as well. And speaking of automation tools, here are the most common ones. So we have Alt-Tester and Game Driver, which are agnostic. So they allow you to write tests with Python, but they're also non-native, so they're using a network interface by default. Whereas the Unity test framework and the Unreal Automation test framework are native to their respective game engine. As you can see, depending on your game engine of choice and the language you're using, you might be limited in your choice of tools. So this is important to decide where you are at in this table. I will give you a few seconds if you need to take a screenshot or absorb the information here, because this is a bit dense. Now, if you want to go further, I invite you to read my blog on gameconductor.net. I've compared the different Unity test framework, and I also maintain a skill tree necessary to become a QA automation engineer in the video game industry. So if you want to look at it, if you want to get curious about it, this is a good starting point. I am also fairly active on LinkedIn, so follow me if you want to learn more about test automation in video games. And that's it for me. So now this would be the time for questions. So I will check the LinkedIn page to see if there is any comments. Let me check. So I will choose this one, for example. I think this is the only question we have so far. So the question is, isn't Android versus iOS versus web a fragmentation that happens to non-games? That's true. We have a lot of fragmentation for mobile apps, for example. That's also why usually they are built with web views, because this is easier to build like a cross-platform app on that. But I think this is more prevalent for video games. And if it was not clear in my presentation, for example, not only you will have to build your game for all the platforms, but your capability to test them will be different according to the platform you're targeting. So for example, if you build a mobile app, you can already test it either if it's a web view or a native mobile app with the tools that are already existing, like Appian, for example. But with video games, you will have to use one of the test framework, and it will be more complicated because the tools, like the UI which is presented, is usually just drawn on the screen, but it's not. You can't inspect it the same way you would do with a mobile app or a web app or a web view inside this kind of platform. So, in my opinion, this is fairly different because it adds a layer of complexity here. So there is one. Will your recording or the deck be available after? So I'm recording that at the moment, and I will try to provide it. I'm not sure exactly how long it will stay on LinkedIn, but I will have an actual high definition version that I will try to post somewhere. How do you determine if something in a game is worthwhile to automate testing for it? Some aspects of the game are bespoke, one-off, that may not be repeated. And this is an excellent question. So unfortunately, my answer it depends, right? It's easier if you have a sense of how hard it will be to automate. As I said, live events, for example, are notoriously a problem to test because you need to take into account the fact that this is, like you say, a one-off. So if it's a regular feature that is live, like a seasonal thing that comes again and again, you can try to have an automated test for it, but you need to understand what is worth testing for this particular feature, even if it will be slightly different every time. So your test may be different. If you build an integration test for that, usually this is easier. If you have an end-to-end test for that, this becomes way more complicated. And I know because I tried it, especially at Wooga for specific live events, and it has been a hassle. Some other live events were easier, but it really depends on how it's built on the backend. And in my opinion, this is really part of how your testing strategy goes with your team. So it can be your own decision, but usually this is done in accordance with the QA team and the dev team. So it will really depend on your situation. I hope it answered the question. Maybe not. If I come with something as a better answer, I will write it later on LinkedIn. Which automation tool is best for Unity games? So this is a question that I don't think has a proper answer, in the sense that it depends on what you are looking for. The choice I've made at Wooga was to use the Unity test framework, and the reason for that is because we wanted to collaborate with the people building the features. So it made sense for us to have a tool that were already so close to the game. If your QA team, and especially the people writing your test automation, are not necessarily embedded in the team building the game, it might be easier to use agnostic tools like Alt-Tester or Game Driver. It depends really on the configuration of your team and your knowledge also of the tech stack. So for example, it's easier to have one programming language for the game and the testing tools, but if you have two different teams, it might not matter that much. For us, this was very important to have like the same level for engineers building the features and the engineers building the test automation. So that's why we used the UTF for that. Can you talk a bit more about the disadvantages of using Python compared to C# in a Unity game? So in my experience, so I've tried the few tools I've listed there, not the one with Unreal, but the one for Unity specifically. And one problem I've seen was if I really wanted to do like some very advanced tests that require some knowledge of the internals of the game, it was harder to use something that was instrumenting the game from the network. And the reason for that is because everything will go through the network, which means that if you want some specific information, it needs to be serialized through the network. And this will be more complicated to do like very specific things. I know that, for example, Altesser and maybe not Altesser, but Game Driver has a way to run the game without the network interface, so maybe this is possible. But this is not something that is specific to Python. This is more like the architecture of the tools that you're using. So it comes with pros and cons, right? And you need to know that before you choose the tool, because it has like a huge impact on how you build test and what is available to you as a team. So what I can advise you is to go on gamecollector.net, where I compared the test framework, especially I talk about this specific part. So maybe it can provide you with a more detailed answer. I hope it answered your question. And thank you. What impact do you think AI will have on test automation in games in short to longer term? So this is very interesting because this is something that everyone talks about right now, especially in terms of not only in video games but in testing. And this is really hard to predict. My own way of approaching things, especially in video games, is to look at a more advanced industry in terms of testing. And this one, for video games, I look at the web industry, for example. I look at their tools and look at what they can do and what are the limits for them, right? And usually, what I see, there are not so many AI tools that do a good job there. At least not to the point where everyone talks about it, right? When Playwright started to be used, everyone was talking about it. Now it's one of the biggest tools used for testing in the web industry. And we don't see that for AI tools. So I don't know if it will come in the future, but my opinion is we are not there yet in terms of test automation for video games. We don't have the right tools to do it at scale, the same way we do it in the web testing industry. And so if we would like to have AI tools, I would prefer to know exactly what test automation look like as a good outcome, right? Like what good test automation look like first. And I don't think the whole industry knows that first. I think a lot of studios don't even know how to use test automation, and using AI directly might not be the right answer. I know that some people work on it, especially for specific parts of testing. So for example, they do smoke test, which works well with test automation with AI. But I'm expected to be better for areas like visual testing, or understanding some stuff that is in the middle between automation and subjectivity of a human testing. I think it will have an impact in terms of hype, but I'm not sure if it will have a direct impact on spreading more automation. I think we're not there yet. I hope it answered your question. You mentioned the lack of standardization. How do you think this problem could be corrected? So I think this is a very interesting question, and my answer is I don't think we will correct that at all, and I don't think it will. It needs to be corrected, and part of the reason is because the nature of the game is to be specific. Of course, like especially in the mobile industry, a lot of games look a bit like each other, but underneath they are very different, and the teams don't necessarily expect the same thing from these games. They don't target it to the same audience according to the theme they are choosing. So games will always be unique in a sense, right? Like they will try to be unique. And so it's hard to think that the underlying technology will also be standardized, for example, as it is the case for the web. I think it doesn't need to be, as long as the tools are good for what we want to do. And for now, there is a consolidation of game engines, so between Unity and Unreal, and I hope in the future Godot will be a major player too. So that's only three game engine, and I think it's okay. It's not like super widespread to the point where we can build good tools for each of these engine. Game team usually don't try to hop between game engine, so if they know one with the specific tools, it might be good enough. I don't think standardization will happen in the game industry. But maybe I'm wrong, and maybe the future will tell me wrong. Actually, that would be a good thing, but I don't believe it will happen. I hope it answered your question. So there is a question here. Following up on being close to the dev team and using Unity Test Framework, this is similar to how I work. Would you have also invested in having tests on device, for instance, via Altester, or is that redundant? This is a good question because in my experience, testing on devices have not been necessarily a need for the QA team I was part of, because their main problem was not dealing with specific hardware. It might have been with specific resolution of specific features or changes, and knowing that the changes were breaking the game before it was deployed in production. And usually Unity does a good job of being cross-platform here. So usually what we found as issues were not hardware specific, and so it was not necessary to run tests on devices. I think this is more interesting if you have really things you want to investigate specific to some specific model. For example, Huawei phones have like this quirk where they don't necessarily have the Google Play Store, and it might break some of the things, right? So like it's where you want to have like specific tests that check that everything is fine. And that's where the Unity Test Framework might not be a good choice because it's harder to run in a device form. And that's where Altester and GameDriver might be better. But it depends on the choice you make and your testing strategy in your game team. What's your experience of taking off true shelf tool like GameDriver? So I didn't test GameDriver, I test Altester. They are probably quite different, especially when it comes to GameDriver. They try to focus on extended reality games and extended reality experiences. So like for specific industries like medical industries. So I can't talk too much about GameDriver. I know the specification of like how it's supposed to work, but from a working experience in the game team, I can't really tell more than that. I think this is like your point of choice here will be if your team is separated from the team that works on the features, and if you want to have like a separated repository, for example, it might be easier with GameDriver and Altester because they have a similar architecture that is instrumenting the game from the network. But I think this is one of the main points, for example, is to have a universal way of addressing objects. So this is one of the things I talked about when I talk about locator strategies. And GameDriver is supposedly making that easier because they have a language for that, which is similar to XPath, for example. Okay, so I don't see any more questions. I think we covered everything. If you have one question right now, I think that would be the time, so I don't miss it. If you have any question you think of after the presentation, so once the stream is off, you can still post it and I will try to answer after the stream. So there is one more question. How do you personally deal with the pesticide paradox in gaming automated testing? So this is something I never heard of actually. So I can't answer that, but I will look into it and try to reply on LinkedIn after. So this way you can have an answer and people can see it too. And one more question, what games are you playing at the moment? So I try to not overbuy too many games, but there are a couple of games I played at the moment, and one of them is an old game. I don't remember from when, maybe 2015, which is called Soma. It's a horror game because I wanted to be in the mood for Halloween. And there is another one, but I'm not sure if I can pronounce it. I think it's Strafat. It's a small game that is a first-person shooter, which is like a one-on-one. It's an indie game, but it's the atmosphere and the decor is very interesting. So I can recommend it. It's a bit it's indie, so it's a bit done like not everything is perfect, but so it's called Straftat. So I'm not sure if that rings a bell to anyone, but yeah. So yeah. So we're almost out of time. So I will wish you a good end of the evening or good end of the day. And I will try to make sure that the content is online after. Anyway, I will have a version that I can post on YouTube if I manage to do that. So I would encourage you to follow me on LinkedIn if you want more information about the stream. So thank you for your time and see you.